Okay, now part F. This is ruin theory, probability ruin, and it also relates to surplus processes. So just to get kicked off, we will remember that our surplus process, which is equal to our, or defined as our initial capital plus CT minus our claims. Now, here we're looking at the probability ruin, which is this, and we're only given initial surplus U and time as our parameters. Now, looking at this thing, if we imagine our probability of ruin is essentially the probability that this is less than 0 for some time that's greater than 0. So if we kind of put these together and we link the different parameters that we're given, U and T, both U and T have a kind of upwards trend with our surplus process. So this increases the value of our surplus, and therefore this decreases the probability ruin. So given this inequality, we know that U2 is greater than U1, and given the same value of time for each, this first section, this is correct, this is fine, it makes sense. The probability ruin for this this middle section is going to be less than or equal to this first section, just because U2 is greater than or equal to U1, and this makes sense and this is fine. However, this third section, there's just a slight issue, because this is only taking into account an initial surplus, and it doesn't take into account, there may be some scenarios where this section is not the case. So even though T can't be equal to 0, it can only be greater than 0, if we imagine some infinitely small value of T, or some very, very small value of T, looking at, let's just say, imagine time is here, and T doesn't have to be a whole number, and it can be any kind of point in time, it doesn't have to be discrete. So we can say that at this point in time, the probability of ruin for U2 when time is, imagine very, very, very close to 0, all these zeros, point ones and things, this probability of ruin is actually going to be less than this probability of ruin, because we're only given the initial surplus here, and this doesn't really encompass time, it doesn't take time into consideration, so the probability of ruin is just naturally going to be higher at any point in time because of this. So I hope that kind of makes sense. That's my thought processes about it. Because it doesn't take time into consideration, then the probability across time of ruin is just going to be naturally higher in general at these lower values of time. I mean, as if time was to be extremely high, then this probably will be the case. But when we're starting our surplus process, the probability of ruin is going to be extremely small, just compared to the probability of ruin that doesn't take into account time as a factor. Okay, G is fairly straightforward. Party promising to sell an underlying asset said to be in a long position. This is false. Oh, also, I'm saying this is false. If you're selling an underlying asset, then you're in a short position. And if you are buying an underlying asset, then you are in a long position for that underlying asset. And it's fairly straightforward. G and H are a part of the financial derivative section. So H under no arbitrage assumptions. So no arbitrage is basically saying you can't take advantage of price discrepancies at the same time, essentially for the same thing. And no tax or transactional costs for market participants. The forward price FT in a forward contract written on asset S at time T for delivery at time T, and risk rate re R is given by this. So this first section, that is completely correct. So for any kind of derivative contract, we use E and we do continuous compounding. As just a general rule of thumb. So that's why E is, present. And we know that E is just RT. And this is just the time difference between delivery time and the time that the contract is written. Usually you can kind of say that the time that the forward contract was written is at, time 0, because we just want that to be kind of the start of our, time. And it makes it a lot simpler as well. However, the only issue here is this. This should be little t. Now, what it's saying, given this formula, is that the forward price is equal to the compounded value, so kind of your interest rate, multiplied by the spot price at delivery, and that's essentially not the case. A forward contract takes into account kind of an initial price and then places an expected value of the future price. So this is, so we have time, so we have ST and then we have FTT, and the way that we get between those two is by compounding this initial price at the time of the writing of the contract. So it's just a case of t's. So the actual formula should be just difficult, FTT is equal to E R T minus T S little t, where this is kind of your initial asset price. This is the interest you're expecting to accrue on that, and the product of those is your forward price. Okay, question 2. So question 2 is pretty much runoff triangles. I think I'll go through A and then cut this one short, and then I'll make a future part. So we're given a generalized runoff triangle based on cumulative payments for the C. And here we have C, it's in the form of Cij. This is, given at the, well, it's not actually given at the start, but this is given Cij, where I is our accident year, J is our development year, and I plus J is less than or equal to N, where in this case N is equal to 3. So we want to calculate the total payments settled by the end of 2008. Okay, so our total payments today, and we're going to kind of remind ourselves that these are cumulative claim payments, so this value takes into account all of these 3. So all we really need to do is sum these 4. So we can say that that is equal to, you can either start with C30 and then C21. and this is a sum of all of the cumulative payments for each individual accident year and their respective development years, and that's fairly straightforward. Okay, second section, calculate the total payments that were settled the same year of the accident occurrence. So this is essentially saying that someone's been in an accident and they've settled the payment, they've settled the claim in the same year. So we're essentially saying all of the payments with a development year of 0. So this is going to be our C00 plus C10 plus C20 plus C30. And that's very straightforward. Provide the total payments that were settled in 2007 corresponding to accidents happening in accident year 1. So we'll look at this. 2007 and let's reread that. Accidents happening in accident year 1. So that's 2006. And these are settled in 2006. These are settled in 2007. So therefore, the total payments that were settled in 2007 corresponding to accidents happening in accident year 1 is C11, which is here. Now, yeah. What else do we have? Calculate the development factor from development year 1 to development year 2, and the development factor from development year 2 to 3. So a development factor could essentially be the just proportional increase in cumulative losses. So to get from 1 to 2, looking at this triangle, we ignore this payment because there is no kind of payment here. And we actually want to get a weighted average based on the proportion. So to be fair, this is just the sum of the cumulative losses in development year 2 divided by development year 1 that are present anyway. So that is C02 plus C12 divided by C01 plus C11. Let's call this development factor 2, and then let's say that we'll call this DF3, and that is just C03 over C02, because again this payment isn't present and this is a projection into the future, so we can only really use these two. So for part V, we're going to use the development factors 2 and 3 that are calculated in the previous question to then work out the accumulated payment for 2010 corresponding to accidents happening in accident year 2. So if we look at our run-off triangle here, we're only bothered about this section, and we're bothered about this final payment that happens to be in 2010. So we can label that C23, which is equal to C21 times by DF2 times by DF3. Now this is a projection, so this is kind of an estimate, as it says in the question, and yeah, so that was question 1 and part A of question 2. I'll go through B and C later.